In this tutorial, we're going to look at how to use the PhET moving man simulation and take a look at position, velocity, and acceleration time graphs in terms of how those graphs would look with constant velocity motion and then again with constant acceleration motion. Okay, so let's begin. In this first section of the lab, you see that we need to first go ahead and click on the chart. So once we download the PhET simulator for Moving Man, we are going to see a screen that looks just like this. Well, we need to click on the Charts tab so that we have all three of these graphs available to us. So click on the Charts graph. Okay, and it's ready to go. Then what we need to do is it says to move the man by dragging him. I don't really want you to do that. Instead, take the blue arrow and move the blue arrow all the way down. If you drag the man, you're going to create a graph unnecessarily on all three of these graphs. So just use the blue arrow and move it all the way down like this. And that moves the man all the way to the far left. In the velocity box, type the number 2. Okay, and as soon as you click outside the box, you can see that the arrow is ready to go, the man is ready to go, and then we can begin. So all we need to do now is press play. We're going to let the simulator run, and we're going to hit stop once the man reaches the end of the track. And then we're going to take a screenshot and paste it right here. You can see that the man is going at a steady pace. So a steady pace is indicating constant velocity, meaning the man is moving and changing his position in the exact same time interval. Same position in the same time interval. Same change in position, rather, in the same time interval. And we can go ahead and stop it right there. So, we've gone almost to the other side completely. And this is the graph that we would take the screenshot of right here. Make sure you get the time down at the bottom. And you can see at the top right here, this is going to tell you how long he traveled for. Okay, the arrow here will give you an indicator of how far he went, 9.75 meters. He didn't quite go the entire 10. So this is giving you an idea of how to run the simulator. You'll have information here, you'll have information here, and you use that to answer the questions and perform the calculations that you need to. Okay, so we're going to take a screenshot and paste that right over here. Okay, and you'll use that information to answer the questions afterwards. In the next section, we're going to hit the clear and reset all. Okay, and if you really just hit reset all, it clears it anyway. Okay, and now the next thing we're going to do the same thing, but we're going to move the moving man all the way to the far right side, and we're going to put a -2 in the velocity box. So go ahead and move the blue arrow all the way up so that he's at the far positive side on the right side, and we're going to put a -2 inside this box right here. Okay, and we're going to press play, and we're going to get a graph. You can see the graphs are sloping downwards or negative, right? Indicative of the fact that he's moving in a negatively defined direction. The reason he's moving in a negatively defined direction is, of course, because we defined going forward or to the right as positive. Therefore, going to the left must be negative. You'll put that screenshot right here and take a few moments to answer the questions provided. When it's asking you to calculate the slope of this blue line, you can go all the way down for a rise and over. I think what I did is I just went down to the t-axis, which is 0, and then all the way over to about, you can see this is about 5 seconds, so -10 over, or -10 meters over 5 seconds. That's the way I did it, but you just need to make sure that you're able to calculate the slope of that blue line, okay, for this question here. Okay, we're going to take a look at a relationship when the acceleration is not zero. Okay, so this is what we're going to do. We're going to reset everything. Do that. Let's reset. Okay, everything is reset. Then what we're going to do is we're going to move the man all the way over to the left, to the far left. So put the blue arrow all the way down, get him to the far left. And then what we're going to do is we're going to type in the acceleration box, right where the green circle is here. We're going to type in the number 1 for the acceleration of 1 meter per second, or 1 meter per second squared. So let's type in the number 1 here. Now, the range here is just far too large. When you see a graph produced, it's going to look almost as if it were 0 because 1 is so close to 0. What I would do is I would use this little magnifying glass and I would zoom in so you can actually see it better. Zoom in so that maybe your range goes to around 10 or negative 10. It'll be much easier to see. Okay, let's go ahead and play the animation. We can see he's starting off slow from rest. And you can see now he's starting to pick up speed, right? He's starting to go faster and faster and faster. And that's what acceleration is all about. It's a change in velocity, right, every second. Now, you want to stop it before you get to the wall right there. So I'm going to kind of clear and move him back and try that one again. There we go. Okay, and stopping the graph right here, we're going to take a screenshot of this. You can see the position graph yields a curve, a positively upward curve. The velocity graph is more of a straight line up, and the acceleration graph is a positive horizontal at the value of 1 meter per second. Now, one of the things we're going to have to do is we're going to have to find the slope of this velocity graph. Okay, now to do that, you have to do rise over run. So the rise is however high we got to. So we can see 6.3 seconds. 6.3 seconds is the farthest we got. And, you know, it's about maybe 6, maybe a little bit more than 6, whatever. But you're gonna estimate your rise and your run slope of that graph. Then you're going to be asked to find the area under this. Well, to find the area, it's the area between the graph and this time axis right here. So the base would be your time of 6.3 seconds, and your height would be however high you think the velocity went to, and then you need to go base times height divided by 2 to get the area of that little triangle that you see right there. Okay, and then of course you're going to paste that over here in this section and answer the questions that support that. And in this last section, we're going to do the exact same thing, but we're going to move the man all the way to the far right side, and we're going to place a -2 inside that box. So let's clear everything. Move him to the far right, and put a -2 in there. Okay, let it run. You can see everything looks the same as it did in the previous example. The only difference is he's moving left instead of right. He's moving in a negative direction instead of a positive direction. Okay, I'm going to re-clear that. Start over. Let me zoom in to about 10, -10. There we go, that's close enough. Okay, and we had an acceleration of -2. You can see everything is sloping downwards. Okay, and this would of course be the screenshot that we're going to take. And again, if we need to calculate the slope, it would be the slope of this line here. If we needed to calculate the area, it'd be the area between that, you know, where the line is and the time axis, which would be this upside down triangle, if it asks you to do so. Okay, so that is the moving man, okay, and this is how we use the different position, velocity, and acceleration functions and input different values to make the simulator move in different ways. And that allows us to explore constant velocity and constant acceleration with this simulator.